Hello, and welcome to episode 46 of The Joy of Coding. My name is Mike Conley. We're going to be hacking on Firefox today. I'm wearing a sweater. It's really rainy out today in Toronto. There was some snow this morning, and now it's rainy, and so I decided I'm going to try something a little different. I tried this a few episodes back, and I'm going to try it again, where I'm going to try and be a little calmer today. And I've heard that some people enjoy it when things are a little bit calmer, and like if they're playing me in the background. I don't know, me rambling in a calmer voice is somewhat soothing. So I'm going to try that today. So, little less yelling, a little calmer. Let me show you my screen. Oh, and we've got soothing transitions as well. And I've got one last thing for you. I found this website called museopen.org, which apparently plays royalty-free classical music. So I'm going to have a little bit of Frédéric Chopin playing in the background there. I hope that's okay. Okay. So, oh, I'm also wearing, my sweater, and I've got a mug of tea. So I invite you to put on a sweater and get a mug of tea as well. And we can have a really, really nice, calm episode today. So, today is episode 46. That's February 24th. And this is the agenda. The agenda, if you're new, is in the additional links section just down below this video. If you're watching it on Airmozilla, just scroll down a little bit and there's this additional links thing, and if you click it, there'll be a link to this agenda. And if you're watching this on YouTube, it'll be in the video description. And if you're watching this on my blog, it'll be somewhere around the video. So here's the agenda. Hopefully there was a little screw up where at the very beginning I wasn't recording, but now I am, so it's okay. And the mic is on. I can see that the signal's coming in. Hopefully everyone can hear me. So I have some updates. Just a couple of updates about various things we've been working on the past couple of episodes. For one thing, last week we were working on this reload refresh blocker thing. There was this special edge case where for, I think it was refreshes that are occurring using the HTTP header. Those cases we weren't blocking properly. We weren't showing the notification bar with E10S. That stuff has the solution I found last week. It got through review. It landed. So you were here when we found the solution. So thumbs up. And if you're interested in seeing that solution come to arrive, then check out episode 45 because that's where it happened. So there's this other one that we were going to work on, but I'm not sure if we ever did, where the user, if they're using a Firefox account and they're in like the accounts setup sort of management UI inside about preferences, and they choose to log in, like connect an account, but then they choose to reset their password using that UI. There was this confusion and what's the use case? If you verified that you'd reset the password, the About Accounts page would show an error message, and that got fixed, and which is great. And what's good about it is that I didn't actually have to do anything. I only had to kind of push on people in the FX Accounts group, and they did everything I needed them to do, and it was great. I've got an initial patch up that makes profile dumping work more reliably with E10S, which is great. And this I don't know if you were around for this, but this has been haunting me for like a month and a half, where I was trying to land this patch, and it got backed out because it was causing a permanent orange, and I couldn't figure out what was going on. It was some kind of leak, and eventually we figured out what the leak was, and apparently my patch fixed half of a leak, but caused a lot of entries to show up in the cycle collector graph, and that caused the shutdown leak. And so we figured that out, and the patches have landed, and I'm very happy about that. One thing I wanted to also mention before we really dive into this, because I do want to keep going and show you some cool stuff, but someone rated me last week, and thank you so much to the people who rate these episodes. There's a link down here in the agenda if you want to rate this episode. You can talk about the music and the calmness of my voice and the sweater and tea, if this is better or worse than normal. And they wanted to remind me that Ricardo from the Mozilla Foundation does live design work on YouTube. He streams it. He hasn't done one in a couple of months, but he was doing it for a while. And if you haven't seen those episodes, they're really, really fascinating. So there's a link here to see Ricardo doing live design work, which is muy bueno. Okay, so what are we doing today? That's a good question. The first thing I want to look at is a T-Paint regression in E10S mode compared to non-E10S mode. And we have profiles. I pushed yesterday this patch up here that makes profile dumping work with E10S. I pushed it to try, and I was able to get some profiles out. And what I didn't notice, or I hadn't been focusing on this bug too much, I've been dealing with other things, but now I can finally come back to this one. And apparently there are some pretty strong regressions with Windows 7 as well. And I think I'm going to shift my, like originally I was doing the analysis on Linux 64, I think, but I'm going to shift my analysis over to Windows 7, and we can take a look at those profiles. So here's the try build. If you want to follow along, I invite you to click on the link at the bottom of my notes. I've linked to the notes from the agenda, and I invite you to click on this link and then follow along as I do what I'm about to do. So there are two things here. I've got two builds. I've got Windows 7 Opt doing the other Talos group. That's what the O stands for. And T-Paint is part of that group. So here's the T-Paint score, 303.06 for non-E10S. And for E10S, it's got 374.88. So we do regress. And down here we've got, because I pushed with the --SPS profile flag, I was able to extract profiles from these machines, which is handy, and now we can take a look at those. And these links are purple because I've clicked on them to make sure they worked, but I haven't actually done any of this analysis yet. So what you're about to see is me analyzing this stuff for the first time. So let's check it out. I'm going to open up the non-E10S profile for comparison. That's so like anything that we... oh, what's that music? A little Baroque. Going for Baroque there. I maybe shift the... gonna find less harpsichord. Yeah, Bach. Give me that Bach. Okay. And then over here we've got the E10S profile. I'm opening that up. Now I'm gonna order them so that on the left we've got the non-E10S profile, and on the right we've got the E10S profile. I tend to do that, where we've got like a regression and something that's not regressed, then I'll put the regression on the right, and that's just a convention of mine. So let me talk about what we're seeing here. What the T-Paint test is we'll have a Firefox window open, and then it will open up a new window, a new browser window, and time how long it takes for the Moz After Paint event, which is the event that fires when the content is painted in that new window. It'll time how long it takes for that event to fire, and then it will close the window. And it will do that a number of times. And what we're seeing in here are the samples that are collected when we start the stopwatch and end the stopwatch for measuring how long it takes. So that's good because it means we only collected samples that we care about. And by samples, I mean we're using a sampling profiler with Gecko and these profiles, which means that every, I guess it was an interval of 1 millisecond, every 1 millisecond we ask Gecko, what are you doing? What are you doing? What are you doing? And we write it down. And so now we have these little windows of time where we can see what Gecko was doing, what Firefox was doing during the test. So here we can see, let's just take a look at one of these. Each of these is the window opening and closing, and then we wait some time, then we open and close. So each one of these is the window opening, and then here's the window closing. So let's take a look at one of these cases where the window is opening. We can zoom in a little bit, and we can see that this took 395 milliseconds, roughly, and then over in the non-E10S case, it took 292 milliseconds. So that's a difference. That's a difference of about 100 milliseconds, which is very interesting. Hopefully there's a strong signal in here that will show us what's going on, what's slowing down. So I'm going to zoom in over here into the non-E10S window, and I'm going to zoom in over here for the E10S stuff. Now there are there's this extra row here in the E10S tab profile, and that's for the content process. So we're sampling the content process and the parent process, and so that way, you know, that's probably what's going on wrong. Is either the parent process or the content process is doing something slowly, or is waiting for something, and that's the problem. Also, if this music is disturbing you, if you don't find it's calm, if you find it distracting, please let me know in IRC or Twitter. I'm monitoring that, and I will turn it right off for you. I find it calming, but maybe you don't. So just let me know. And who knows, maybe you've got... I hope that the royalty music I found isn't going to mean that YouTube's going to DMCA my videos when I mirror them over there. Okay, so what have we got? This is the Cleopatra UI, and we've got the start of the test here and the end of the test, like the single window opening and closing. And right away I can see that we're doing some, like these here are sync IPC messages are being sent, and that's usually a bad sign. We do that one time in the non-Ethernet case. That's probably going to the compositor to like a layer transaction to the compositor or something. And let's see. This is handy over here on the right because it shows you of all the samples that you're looking at right now. So each green line represents a sample, and the height of the line represents how deep it is inside the call stack. So it has no relation. The height has no relation to time. It's just deepness. Now there's a sort of a subtle color shift. It's a little clearer over here, and this color shift as we go closer and closer to this red, and you should ignore the red from the compositor thread over here because it's always red. But in the content and Gecko main processes, whenever the samples start turning red, what that means is we haven't gone back to the event loop in quite some time. Like we've been doing other things and not, responding to events from either the user or going back to the event loop, so being responsive. And so that's a good indicator that something is slowing down. In the non-ETNS case, there's a slight shift to the red, but then it relaxes right here. So, but it seems to be worse for the ETNS case, especially down here in the content process. Now notice here as well, the stopwatch stop occurs 54 milliseconds in. That stopwatch stop thing, let me show you what that means. I refactored T-Paint to use the new profiler scripts. And what that stopwatch stop means is I set a marker in the content process as soon as, because the pausing and the starting of the profiler involves messaging to the parent. And so some of that will take time. It'll take time for the parent to process those messages. So I've got a marker here that says we've stopped, we stopped recording time. Like we record the time of how long it took to open the child window here in kid end time. And so anything after T-Paint stopwatch stop is no longer, we no longer care about it. So we can chuck all of these samples right out. We do not care. So that gets rid of 54 milliseconds of the samples, which is nice. It's everything before that we care about. So I'm actually going to zoom in a little bit here. Stopwatch stop, yeah. So there's a big sync IPC message from the content process here, and that's not too surprising because what we're doing is we're waiting for the parent to give us the DOM window, or sorry, to give us the tab child that we're going to load the content in. So the parent is actually doing the work of asking the operating system to create a window for us, and then it's, rendering the Zool of that window. And whenever it gets to the point where it creates the remote browser in the new window, it gets a reference to the tab parent and then messages that down to the child, which translates to a tab child, and the tab child is a thing that can have a document loaded into it. And until we get that, the child process is blocked. And that's not unusual. The child process, when we do the opening of a window in single process mode, we will block the execution of the open, what is it? Open new content window right here. Where is it? Open window. This is essentially blocking the execution of open window for the same, a significant amount of time. In this case, it's taking about 236 milliseconds, and that, let's see how that corresponds here. Yeah, it's similar. It's a little bit more in the E10S world, but it's roughly similar. So we're spending, and so the extra couple of milliseconds might be accounted for by IPC traffic. So the cost of opening the window in the parent process is probably the same. Let's see, we receive the create window and we spend 244 milliseconds, whereas over here we spend 236. Okay, so there is a slight increase in the amount of time we're spending opening the window in the E10S case. But I think we have bigger fish to fry. I think that the stuff that happens after is more interesting. So let's take a look at this stuff over here, and maybe there's some clues. This is 65 milliseconds in the E10S case, and over here, how many is it? Oh, it's 72 milliseconds. T-Paint, stopwatch stop. How long does it take? 63 milliseconds is the after stuff, and it's 65 milliseconds. So maybe this is the stuff that we care about over here. Interesting. Like, how much is the difference now that we've zoomed into where the stopwatch stops? 311 milliseconds versus 200 and how much was it? 299. So there's only an 11 millisecond difference in this case, which is interesting. That's far less than what's being reported in the test. So I'm going to write down that piece of information. Well, maybe I can confirm that. Let me, whenever the tests are output, like whenever we log, sorry, this music is quite intense. I'm going to fast track ourselves to another track, Schumann. Grieg, I like it. Oh, that's what I'm talking about. Nice and calm. T-Paint. Whenever T-Paint runs, at the very end of the test, it's going to spew out the results of its run. Let's see. And here are the results. It reports how long? Oh, that's DHTML. I'm looking for tpaint.html. T-Paint. So this is all the runs. This is the opening and the closing of the windows. There's an error here. It's interesting. And then it's posting results. And the results are a T-Paint score of 378.88. Or 74.88, I'm sorry. 374.88. And where are the individual run scores here? T-Paint. Subtests. No. Where? I feel like there's a far easier way of reading this somewhere. T-Paint outputs, what does it output? Dump log, opening time. Opening times. Here we go. So in its single run, the opening times are 358, 358, 358, 359, and then notice that it's increasing. That's very interesting. It gets worse and worse and worse over time. Is that true for the single process case? Because maybe that's where the problem is. Maybe I'm looking, because remember, I zoomed in on the single run, and while it is slightly slower, it doesn't really account for the difference. 278, 284, it does seem to get progressively slower. Whoa, that last one's really slow. Median of 293. So the first one was 278 for the non-E10S case, and the first one over here for the E10S case was 358. 278, 358. Let's do some basic mathematics. So the logs indicate the following. Non-E10S case. Let's put this stuff in here so I don't have to keep referring to it. I can derive the other values. Oh, so E10S case. And here we are. We have some opening times here. So right now we're looking at this one, 358 and 278. And let's see if that is reflected in the profile samples we're currently looking at. Oh, I've also realized that I need to plug in this laptop. Let me just do that calmly. It's nice, calm music. I should have a sip of my tea. Calm voice. Everything is calm. Okay. Let's see. So 278 milliseconds. Does that make sense? So in the single process case, now there's going to be a little bit of error because well, am I looking at the right one? Maybe it throws away one. There are how many test runs here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So am I looking at the wrong ones? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So maybe this is the one I should be looking at. Or maybe it's this one I don't care about. T-Paint 9, T-Paint O. Like maybe T-Paint O, T-Paint 9. What does it do with the numbers? Open times, slice, it'll slice 1. I have to remember, again, what does slice 1 mean? If I have an array of things, what does x slice 1? I always forget. It's chopping off the first. Okay, so that's neat. That's good to know. Note, T-Paint chops off the first value when reporting results. Okay, so really the measurement that we care about is the second one. Or at least that's the one that corresponds to this value of 278. 278. So we should be looking at the second window opening in the profiles. So 278. That's what we expect in here to be about the distance between here and here. And we're off by about 20 milliseconds. Well, something like that. And over here, how far are we off? If it's 358, let's go out. And we're looking at the second one. It's got to think about it. Nice and calm, nice and calm. It probably doesn't help that I'm doing a build in the background. That's probably not helping my my processing of these profiles. The stopwatch stops around here, which is 310 milliseconds, which is quite a bit lower than 358, which is what? 364 milliseconds. So I wonder if the test is misreporting somehow. Now, end timestamp. Let's take a look. The open times that we care about take the performance now minus the kid's start time. So we'll open a window. Hang on a second. I have to go back to my patch that I added over here for T-Paint. T-Paint runs. The window is opened, and we record the end time. And then we schedule kid start time. Maybe I should record performance now as a static number. I don't see why it would make any difference. Kid start time. We start. We say, here's the profile marker for having started. And then we record the start time. We open the window. When the child is open, we call window opener child is open. So that goes over here. We record the end time. And then we record the delta. Open times window index becomes the delta. And then over here, when we finish, what do? We go over the open times and we calculate. Oh, we're calculating the min and the max and the average. Interesting. So hypothesis 1. In the E10S case, T-Paint is being misrecorded. Recorded, reported. And is somehow waiting until the profiler stops sampling. This seems unlikely, but somehow matches what I'm seeing with the times being reported. Because 358 is being reported as the time, but if we look at the point at which the time is stopped, the stopwatch is stopped, that's less than that amount of time. Now it's also possible that that this marker is in the wrong place, that for some reason these two it's possible that I can't trust this marker. Maybe that's it. On page show, running content.js. We wait for a sync notify here. We're interpreting from browser child. Do we ever see script from tpaint.html being run? Yes. Yes, we do. In open window. And then what? And then... It's probably too fast to... What do we... Hang on. Let me move the profiling stuff on top of tip here. I hope this episode is pleasing to you. Please let me know. There is a rating link in the agenda, and I will remind you again at the end of the episode, and you can let me know what you thought. Maybe this calmer voice is less enjoyable for you. Maybe it is annoying, and I would like to hear that, if it is the case. Okay, so I have done the rebase, which means now T-Paint should be, well, oh, I have to update to it. So now, what have we got? The way the window works is, we load this data URI that adds an event listener to Moz Afterpaint in the capturing phase, and then whenever it sees that event, it's going to call child is open, which does the recording of kid end time. And that's what we're apparently dealing with over here. And then it does a close. So I wonder if we see a stop, which might signal that we can trust this T-Paint. This T-Paint stopwatch stop marker. The press shell is still initializing. And we're still loading the URI. Should load URI. You know what? I don't know if we can. I wonder if maybe this profile marker is suspect. Okay, let's assume for a second that we cannot trust that profile marker. Can we find out whenever... So we return to the event loop here. That to me strikes me as the most likely point at which we would have executed the close request, or we said to the parent, okay, close this window now. If we invoke the JS, location's changed. When is the close occurring? Get input. Forwarding stuff. Waiting. Deep in a call stack. In reader mode. Huh. The page show event was fired there. We're initializing some things. So let's assume instead that this entire, like, we end T-Paint. Well, one thing we could do in the content process. Oh, T-Paint stopwatch stop. No, I don't know what to do in this case. Like, I really want to trust this marker. I don't know if I can. We're invoking some JavaScript. Oh, we send a blocking message. What blocking message? Send a sync message. And where's that coming from? Browser child. That comes when we send probably the init message in browser child. And here, and state change, we're sending messages to the parent. Alright, so let's break it down. There are a couple of problems here. The first problem is this. There's a sync message being sent, one right after the other. There are two sync messages right in a row. The second sync message takes 50 milliseconds. Excuse me. And the sync message is to send get render frame info. So we tell the parent to create us a window, and then after we get that window reference back, we then ask the parent to give us information about the render frame of this window, of the browser that was just created. And I wonder if we could combine these two. That is a thing I had already highlighted as a potential solution before in my Linux analysis. That is, I think, the first big win. Where would that be? Thought I had a note on that, but I'm gonna just add one to the bottom. One, combine p content send create window with p browser send get render frame info. Okay, so that's a thing I can file, and that takes a while. And the reason it takes a while is because the parent is doing other things. It's busy. The child goes off and asks this question. Meanwhile, the parent is executing all of this stuff up here. It's loading message manager stuff. Content.js is running. That's strange. Why? And then we look at the component manager. Content.js runs. And delayed startup. Oh, social UI is initting. Okay. So the parent is freed up to do all this other stuff. And the child is asking for big important things, and the parent cannot service it because the parent is busy. The extension, we start loading remote scripts here. We're loading a bunch of remote scripts. That takes 14 milliseconds. The majority of that time is being spent loading tab content. It's only 4 samples though, then the rest of these are just 2 milliseconds, maybe 1 millisecond here. We set the initial, we create the about blank content viewer. That takes a little while. Unwrap native kapow. Interesting. What could that mean? We do a stop. We stop the doc shell. And then the profiler has some samples in here. We probably shouldn't have those, but we do. There's a bunch of stuff in here that I don't think is super useful. We receive some things from the parent, like an update in our dimensions, a message to activate. That message to activate results in a sync message going up to the parent, because we ask the parent for the input context over IME, and we spend 5 milliseconds. Oh, applause! Applause! Thank you, thank you. Oh, you're too kind. Same again with IME over here. Another sync message. So I'd say we spend in total about something like 10 milliseconds getting IME state from the parent. That on top of 50 milliseconds. We spend 50 milliseconds waiting. Wow, that's a lot of clapping. I mean, wow, there's like a bunch of minutes left. I hope it's not all clapping. Okay, there we go. Letitia Hahn, big applause. Big applause for Letitia. Okay. We spend 50 milliseconds waiting to hear from the parent about the render frame info. So that gives us 60 milliseconds, and we're looking for a difference of about, I'm gonna pull up a calculator because I can't do math in my head. 358 minus 278 is 80. So now we have something like 60 milliseconds accounted for. We're missing approximately 80 milliseconds. And I've accounted for 60 of them, so we're looking for 20 more milliseconds. Where did 20 milliseconds go? So let's take a look at these samples. I'm also going to look at these samples. So 70 milliseconds are spent over here, and 70 milliseconds are spent over here, but maybe they are distributed differently. One way we can analyze that is by inverting the call stack. That puts everything on its head and shows me everything at the bottom of the call stacks, but on top of the tree here. So I'm going to invert the call stacks, and now I can analyze, like do a difference in ordering. So I'm going to open both of these side by side, and we can just sort of analyze visually. Whoop, 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 whoop. There. So a mem set's occurring. So wow, we're doing a lot more waiting. That means waiting, like waiting for a message from another process because we're blocking. We're doing much more waiting in the E10S case. Here we're only waiting in a few places. Over here, we're searching a table. That only takes 2 milliseconds over here. We're doing mem sets over here. There's really nothing too expensive. A lot of 1 millisecond things going on here. Well, actually, a lot more 1 millisecond things going on in the non-E10S case. Oh, and I am looking at the parent process just now, or the content process just now, and I should probably compare these two. Another thing I can do is I can also just look at JavaScript. Maybe there are JavaScript things that are being particularly slow. Not really. Now these are, I'm not seeing tab, Windows preview per tab. I'm not seeing that in the non-E10S case. And tab previews. That's interesting. Oh wait, no, there's a create tab preview down here. Some BUI on page proxy state. That's a bookmarks user interface. Location change. No. not too bad. I don't see anything in there that jumps out at me. And in the content process, open window is taking about the same time. I have this extension global thing, set up JSON, and knitting browser content. And it's possible lots of little things are adding up to the missing, how many? The missing 20 milliseconds. So another thing I could do, I assumed that the difference was down here, but like, it's also possible that if I zoom in for the entirety of the profile, so I'm gonna zoom out again, that we'll see something. Now that we're inverting the call stack entirely, I can see that open window is taking much longer in the E10S case. Much, much longer. It's actually running in parallel to a bunch of other things in the non-E10S case. Here it runs sort of in parallel to other things, like smaller things. And the extension content stuff starts up, I guess. But here it's interspersed with many other things. And maybe that's okay because of the parent process doing certain things at the same time. Let's take a look at the parent process now. Infer from text is taking the same amount of time. The tab browser constructor is taking about the same time. Onload and delayed startup. Delayed startup takes about the same time. Onload is taking slightly longer actually, but I don't know if that is going to account for it. Lots of things are starting up when you open a window. Lots of things start up. Pocket overlays. Pocket overlay. The search bar XBL constructor, like we start constructing all of these different things. We update the browser remoteness here because we force the initial browser to be remote. That's unique to E10S, so there's 3 milliseconds. 3 milliseconds, we spend about 3 milliseconds updating the initial browser of the opened window to be remote. So now we are missing 17 milliseconds approximately. Okay, let's turn off JavaScript only. I don't think that's where the time is being spent in JavaScript. We still have our inverted call stacks. Yeah, much more waiting. Some selector matches in the parent process because of what? Because we're doing what? We're initializing the layout of the Zool window. Selector matches takes 5 milliseconds. It takes 8 over here. Why? Content enum selector matches takes 2. Then we've got these selector matches tree and then restricted selector matches. Conditionally restyle. Where's that? Well, that's new because we're doing a flush. Do we happen to do more style flushes in the E10S case? That's worth pursuing. Those are always fun. That takes time. Interpreting takes less time. Interpreting JavaScript takes less time in the parent process. What about the content process over here? Whoops, see daisy. We're spending a lot of time waiting. like the majority of it. One thing I know that we do is that when the browser process, when the child inits, at the very end, the browser child is associated with a remote browser. At the very end, it will send a sync message to the parent, and that might be slowing us down a little bit. I think I did an experiment with that earlier. We spend X amount of time waiting for the parent to respond to the browser init message. Let's see if I can find that in here. That'll be right at the end. The browser init message. Ooh, some cycle collection. Or there's a promise that's being invoked. Keep forgetting I've inverted the call stack here. I'm looking for the sync message where we ask the parent for that browser. We send the browser init. Here it is. Here it is. So you spend about 2 milliseconds. That's not so much, but still, that's unique to browser child. What else is browser child doing? Yeah, what do you do? Zoom manager. Whoopsie daisy. No, where's the sync message? I'm certain there's a sync message in here somewhere. There has to be, or is it right next to it? Oh, here. On process next event, wait for message. Base app shell processing events. Oh, that's just waiting for input. How about over here? Sending a sync message. For vsync. Maybe the browser init. Where would that be sent? Oh, is this it? Yeah, I think this is it. We send the sync message here. Yes. It happens very early, right there, but it doesn't last very long. Okay, only about 1 millisecond. 1 millisecond. That's not so bad. So we have about 16 milliseconds remaining. Okay, what else we got? Let's think about reflows and repaints. Do we spend more time doing that here? So let's say restyle. And the parent, 59 samples. We're looking at restyles here. About 58 samples, that's no bad. Reflow, 44 samples. Parent, Ethernet case, 46. Okay. What about, oh, are we reflowing down the content process? So resize reflow. That's supposedly after we stop the stopwatch. Reflow, how about paint? 327 milliseconds in the E10S case. 200, oh. Well, hang on, there's a bunch of stuff. T-paint, the word T-paint. I'm looking for something else. I'm looking for like actual painting. So like graphics, I'm looking for the graphics stack. Paint. Where do you paint? Yeah, and it's press shell, paint, press shell. Whoops, 2 L's in press shell. 13 samples. This is very calm, I think. Listen to this dude sing. So we do seem to spend a bit more time painting here. 25 milliseconds versus 13. And so if I do my math right, that's about 12 milliseconds, which almost accounts for the rest of it. Now, is that worth looking at? What kind of painting are we doing? What kind of painting are we doing? We receive a window, or we receive size open dock shell item. That will cause us to paint the window when we create the window. Okay, so we've painted the window. Let's invert the call stack again. Spend more time getting a property list. Wow, there's just a lot of single sample things in here. Transform. Cairo stuff, graphics. I don't feel confident about my analysis here. Here's another thing is, what is this, display list? Do we compute the display list? Apparently display list computation is slightly slower with APZ. We should test with APZ disabled. Okay. Okay, so I think here's what I want to do. This I can't do yet. That's actually high cost, but I definitely can test with APZ disabled. And I want to be more confident that the stopwatch marker is in the right place. And I think I can do that by logging some things. So let's try and do that, and then let's move on to other stuff. So I'm going to, what am I going to do? I'm going to repush, and close these profiles out. We're going to do this again, but what am I going to do? I want to verify this locally first. Stopwatch stop, performance now. I'll have it report the time. Stopwatch stop, kid end time. Stopwatch stop, no, I'll have it record the delta. I'll compute the delta here. delta equal stop delta. I assume T-Paint is opened in a remote browser. Yes, it would be. Yes, it is, because I saw those samples inside. Okay, that's good. So we'll add some dump statements here. And then what are we going to do? That way we can be confident about our delta. I think that's what I want to do. So let's see if this works. I also want to reduce, here's the other thing, I have to reduce the number of times that T-Paint runs, otherwise the profiles get too big. We don't do any monkeying around with open times, do we? No. Okay. So let's try running this. Talos test a T-Paint E10S SPS profile. So a thing I was also thinking of doing with this calm music was to have Rainy Mood, which is like the sound of a storm playing in the background, going in the back to go with our rainy outsides here. But it sounded too much like static.
You are?
Now here's the thing. It's not possible that the window performance is disagreeing, is it? No, I don't think it is possible. I'm gonna have this dump too. Windows saw Moz after paint at, and then window.performance.now. I'll do it again. And then I also want to disable APZ, and then we will see if that improves things. Whoopsie daisy. Unterminated string literal. Doesn't like that. I did not code that right. Terminated string literal, where would that be? Performance now. Dump. After paint. At. Close parentheses. It would be clear if I did it in those magic template string quotes. You gonna like that? I think you're gonna like that. I don't know where the breakdown occurred, but sometimes it's not clear where when you have strings emulating being meta strings that I just spilled water all over myself. I'm that calm. Oh, what are you doing? Dump. Windows Sawmaz. Oh, you know what? I don't think I can put those quotes in there. Or backslashes. See what you think of that. Maybe this is going too far. Maybe I don't need this. Wow, this music is very intense. Okay, this is good. This is interesting. Different windows have different notions of what performance.now is. I guess based on the lifetime of the window. Okay, well let's take a look at our profile here locally. See if sorry, I need to open that up, and I'm gonna respond to Lizard and IRC. Okay. Let's take a look. Cleopatra. Okay, so stopwatch stop. You know what? I don't believe these profile markers are in the right spot. Because we are still opening the window at this point. I think these stopwatch markers are bogus. So here's what I'm going to do. Instead of doing a stopwatch, what I'll do is I'll get rid of that. Don't need that. I'm gonna now equal date.now while now I'm gonna call this then. This is really sloppy. Minus then is less than 200 milliseconds. Just gonna kill time for 200. I'm gonna block for 200 milliseconds, and that will be very clear in the profile. So I'll know when that occurs in the content process and know that at that point we do not care. So anything, any samples after, during or after that blocking the content process, we will not care. We'll of course need to subtract that time. We'll need to ignore all the samples there and like zoom in Cleopatra. Okay, let's take a look. Right, so I can see exactly where the... Whoop. Yeah, that's where I'm doing the for loop. Waiting right there. Interesting. Till date. Next. So we wait to run the for loop for this amount of time? What is this stuff? We're waiting for what? Block until next event matches list in mode with filter. Event. Why would we wait? Why are we waiting? What are we waiting in here for? Before running this stuff? That's a question. Because I guess we don't hear... Why? 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 We don't execute this script until here. Why? It's done right here. Because we received the message that we composited. And are we waiting to hear that we composited so the painting... It takes longer for the content to hear that we composited. So we're waiting at this point. The reason we're waiting is we're waiting for the compositor in the E10. This is on OS X anyways, but this is still interesting. And then we go. Okay, so I think I'm happy with this. The last thing I want to do is disable APZ. Whoopsie daisy. Layers async pan zoom enabled. I'm going to disable APZ in the T-Paint test. Preferences equals false. And that's it. Wait a second. File URL. Yeah, we do load file URLs in the content process. Okay. We're okay there. And okay, I'm happy with this. Let's push this to try and see what we get. And let's call this on, we'll say this is on pause until next time. So we'll commit T-Paint win 7. I'm actually gonna push to, yeah, I'll commit it. T-Paint win 7 experiments. Now I'll push to try. Whoops. Didn't copy that right, I guess. I hope this has been a soothing episode of The Joy of Coding for you. Up next, I think what I want to do, so I'm testing with APZ disabled. I'm gonna... I am 100% less confident that the stopwatch marker is in the right place, but I've added a hacky wait and we'll file a follow-up to get the stopwatch marker placed correctly. So, follow-ups. To do, file follow up about stopwatch marker being not placed correctly. And here is the try build. And we'll wait for our profiles to come in there. Great. Okay, so I'm going to put this on hold. We are blocked on a try build. And if perf work, I think if Mossip, if you're watching, if perf work and profile analysis was what you were interested in, I'm done with that now. So you can stop watching, unless you want to watch the rest of what I'm doing. Mossip's great. Everyone here, if you're watching and you're curious to know who Mossip is, he's outstanding and helped review that refresh blocker stuff, which was great. So what else did I want to do today? I'm done this thing for now. I have some reviews I can do. I got about 15 minutes. I'm going to try and review some patches, and then I'm going to call it a day. What do I hear in the background there? Who's playing? Who's playing? Wagner from the European Archive. Die Meistersinger, part 1 of 6. Let's see if we can get something a little more reviewy. Beethoven, perfect. But I think I want something. Oh, the Well-Tempered Clavier. I like this. This will be our review music. Yes, this is exactly right. Now, what's going on here? So it looks like Heiss requested a review on part of this, but not on the other part. Or he canceled the review on the other part. Let's see if we can review this first part. So apparently the char set menu is not working in E10S mode, which is a surprise to me. Let's go to a page where we might want to use the character set menu item, the text encoding menu. Like if I go, it's disabled here, but if I go to like Japanese books, or like oh yeah, what's this? I don't know what site this is, but I don't know what I'm looking at. Some kind of seminar site, but text encoding apparently works here. Let me say Unicode, Western. Yeah, that's changing things. So Unicode's working here. Auto detect Japanese. And this is an E10S window. So what's the dealie? Why do you say this is busted? Just not working. Still broken, and the tests are indicative of the brokenness. So I'm going to ask Heiss in FX Team. I'm going to ping him, see if he can articulate the brokenness, so I know what exactly is being fixed and why. And in the meantime, we can look at the patch just to see if what he's doing makes sense. It's good to understand Oh, Pongish running away 10 minutes. What's up? Perfect. That's about as much time as I have left in my live stream. Mind talking to me on my live stream? You are off camera right now. If it's not cool, let me know. On IRC, not video. Cool. So I'm going to bring Heiss over here so you can see the conversation. Hey, so I had some questions about bug 1088710. I'm looking at the first patch, I just tested the character encoding menu, and it seems to work all right. What about it is broken? Or is it the tests that are broken? I don't... One sec. Like, do you have STR for me to see the broken behavior? So the first patch, which while I'm waiting for high second, so the test is broken, is failing, not because of being incompatible, being an incompatible E10S test, but because the feature is actually busted. Okay. It should have Unicode selected. I see. Okay. Fair enough. Great. I think I understand. So I think it's the menu item itself seems to work. It's the defaults in the menu item are busted. Let's take a look at the test that he's referring to. Same thing in the widget, but there's more free. So you can move into the toolbar. Let's take a look at this test that he pointed out and see what it's doing. So what this test does is it adds the character encoding button to the panel, opens the panel, and then gets the character encoding button, makes sure it is there, and then makes sure that it is initially disabled. Then we hide the panel. Then we load the character encoding page. That's the one that Heis referred to. What? Right. Character encoding page, which says that it's a UTF-8 char set page. See also tail end of. The try push shows that one of these tests, but not the other, still fails in Linux. So just triggering on the test locally in Windows where I wrote the patch to pass, even if I run the directory up to the test. I don't know why it would behave differently on Linux. There are no Windows try results yet. With some tomorrow, potentially if I scan Linux VM, see what's going on. In general, what this change that is fixing is that on location change can fire before the document's charge set has been set appropriately. In an E10S, we never update again after that, which then breaks the test expectation that the charge set is Unicode rather than Western. I don't know why this fix would somehow work on my Windows machine and on the Linux machine, unless HTTPD.js is sending a char set as an HTTP header by default, and that char set changes per OS or something. Good question. Spooky. Okay, so we load a UTF-8 page. We show the panel again. It should be enabled. Then we click the button. And then we should be showing the panel. We get the pinned encodings. We get the encoding view, char sets. There should be 2 checked items. The encoding, the Unicode encoding should be selected. Then we hide the panel. Okay. I see. So basically, we should load this page and see that the Unicode. Let's view the raw. So I'm seeing Unicode, but the test is not. And I could probably reproduce this. But but the test is probably disabled with E10S. Yeah, skip if E10S. Okay, so the first part of his patch, he's the one working on that bug, so I'm not going to try and solve it, but I am going to review his patch here, the first part anyways. So he's fixing some leftover gunk from pre-Australis menu button. Right, because the character encoding menu already existed. It existed for a long time in various forms, and then we converted it to an Australis widget, and apparently there's some leftover gunk that we can remove. So he's removing some things, we're ignoring. So I was looking at this before. One thing I noticed is that this omit access keys pragma is no longer being used anywhere in the tree. So it makes sense to remove it. So we no longer make it possible to omit access keys. So that means that we are defaulting probably to false on that. So that means that we should include the access key here. And if we're changing it so that we never call with false on pop-up showing as the second argument. Right, and because the charset menu second argument was show access keys, and now we're getting rid of it. Right. Show access keys is true. Are there other consumers of charset menu that might charset menu .build. Anyone else calling? Okay, and now let me check the other trees. CDXR charset menu build. So there are other consumers of this interface. Okay, there are other consumers of this interface that are passing things to, like here's false. So we're going to break them if we don't handle this case. So what I'm going to suggest is this is going to break other consumers of charset menu. I can see that both SeaMonkey and Thunderbird use it. Can we detect when show access keys when the second argument is being passed and show a deprecated warning and just ignore it? I see both are passing true as the second argument. So bypass. So I don't think there are too many consumers that are using the false case. So I don't think both are passing true. So I would wager that there aren't too many consumers passing false for the second argument. Can we detect when the second argument is being passed and show a deprecated warning and just ignore it instead? And then maybe file bugs to update the SMTB callers. Now I'm also going to off screen, because I don't know if I'm supposed to show you this, but we have the ability to search the source code of many add-ons. We like any add-ons that are on AMO, We have the ability to search their source code if they've posted their source, and it's under sort of lock and key. It's not open because some of those add-ons are closed source. But we use this to check to see whether or not we're breaking interfaces that other people are using. So let me see if anyone is using charset.build. Yeah, I see just a few users, just not too many. So I'm going to report that as well. So where's that to me? I just checked add-ons MXR, and I only see a few users there as well. Then maybe set add-on compat on this bug. Or maybe dev doc needed or something. And then update. Is there like a char set menu documentation page? Is there anything about char set menu? Doesn't look like it. Okay. Now, what is Heist saying? Heist, what did he say? What did you say? Oh, though for completeness, there's test bustage too in the sense that it was removing tabs and expecting that to be sync, and so on each test you get complaints from OKTest and the test left tabs behind, so that no longer are the patch that he removed review, also just that by using promise test utils thingies. Cool, thanks. Alright, so that's Heist. Boom. So I've got that. I wanted him to warn there. Or is it much cost to leave support for this behind? Or should we consider leaving? We won't leave it. The less we have to maintain, the better. If people really want it, they can fork charsetmenu.jsm. They can add the support themselves. Okay, and then here, what do we do? When we update the current char set, I'm guessing that's being passed the menu. Yeah, the menu list. We get the fold char set, select character set. Is selected. Oh, that's just being more efficient. That's a good idea. And you get just selected char set. Okay, so I'm gonna arc plus this, finish review. R equals me with caveats, see below. Thanks for cleaning this up. Wabam. Okay. I think I'm gonna call this episode done. We did this review. We didn't do this one. This is a little more intensive. I don't know what this one is. Which one is this? Oh yeah, a new Talos test from, or updating a Talos test. We'll look at that later. So I'm going to call this episode done. Thank you so much for watching a calmer, rainy mood, mug and sweater episode of The Joy of Coding. I hope this was a calm and pleasant experience for you. And maybe it's, you know what? I'm going to turn that music down now. I'm going to maybe stop it. Thank you, Ludwig. Boom. let me know what you thought. So I'm going to go back to the agenda here. There's this rate this episode link right here, and if you click this link, you can let me know what you thought. Did you like the performance work, the profile analysis work? Did you like uh, the music? Did you like the calmness of my voice? Is that what you prefer? Let me know what you think. Maybe you are more interested in the reviewing. I know some of you have reported that you really want me to see want to see me fix more bugs. So next week I'm going to do some bug fixing. I swear. And I'm listening. I can hear you. So let me know. Rate the episode and let me know. So just click this link. I'd love to hear from you. I want to remind you again to check out Ricardo's Hour of Design. There's this link here in the agenda. Do check it out. The dude's brilliant. He's the best. So check it out. Also, I wanted to let you know that if you use iTunes or Kodi, you can subscribe to all of the live hacking that's done on Air Mozilla here by using this link. You can add that to your feed for iTunes or Kodi or any kind of media stream reader. And that we want to see other shows in the Mozilla community on Air Mozilla. So if you are doing something out there, who knows what you're doing? Maybe you're doing policy work with the foundation. Maybe you are doing, I don't know, there's so many things that go on in Mozilla. Maybe you're on the ground doing user research out in the middle of, who knows, Europe, or maybe you've just landed in Brazil and you're doing UX research or something, or maybe you are a localizer. Maybe you translate strings to make it so that Firefox works and looks right in different languages and different locales. I think it'd be awesome to see how other people do their work. And so I encourage you to join us and put up some shows on Air Mozilla. So there's a live hacking IRC channel where you can talk and talk to myself or Richard. I'm M. Conley. He's just capital R Richard in the live hacking channel. And get in touch with us, and we will tell you the things you need to do in order to get a show up and running. You don't even have to talk. You can just show people what you're doing. You don't have to be on camera. You don't have to do anything you don't want. You don't have to play music. You make the show the way you want it. And it's just a great way of showing people out there in the world what we in the Mozilla community are doing, what we're up to. So I just want to extend that invitation. And I think I'm going to call this episode done. So I'm going to do a fade transition back to me surrounded by the logo here. Gonna hug you. I got a blue spot on my head. My fingers are weirdly transparent. What? I don't know how that works, but that's what's going on. Thank you so much for watching episode 46 of The Joy of Coding, a calmer episode. Let me know what you thought, and I will hopefully see you next week for episode 47. Take care. Bye-bye.
The joy of coding.
See ya.